So now we know something about the concentration of H plus and the concentration of OH minus and kind of how those two things are related to each other, right? They're always related through Kw, which is 1 times 10 to the negative 14. So what that means is that depending on if we have an acidic solution, we're going to have more H plus than we are going to have OH minus. If we have a basic solution, it's going to be the other way around. If we have a neutral solution, they're going to be exactly equal. And we're going to have a concentration of 1 times 10 to the negative 7th. Now, dealing always with these kind of always with scientific notation and these kind of very negative exponents and all this other kind of stuff gets to be annoying, right? And so, of course, we decided, well, let's not do that anymore. Let's find a different way to express these numbers, and that way is the pH scale, right? And so the pH scale basically says that anytime we know the concentration of H plus, we can figure out the pH. And so in this case, we're now going to use the log base 10 because everything is expressed in scientific notation. And so the pH is always going to equal the negative log of the concentration of H plus. Right? So in a neutral solution, remember in the previous video, we figured out that in a neutral solution, the concentration of H plus equals 1 times 10 to the negative 7th. Right? And so if we take the negative log of that, because this is log base 10, that means the log of that value is just going to be the exponent. So we get negative 7. And so in a neutral solution, the pH is 7. Now that's probably a fact that you already knew, but this is where that comes from, right? When we know the Kw and can figure out what a neutral solution, what the concentration of H plus is in the solution, then we know that the pH has to be 7 because of how we define pH. In acidic solutions, have higher H plus concentrations, right? And that makes sense because remember when we have an acid plus H2O, we're creating products, the hydronium ion products, right? That's the definition of a Bronsted acid-base reaction. Right? If we have an acid plus water, we're creating H3O plus. So if we're in acidic solution, that means we've got acid in there. That means we're making more H3O plus, which means we're going to have a higher H plus concentration. So the larger H plus gets, the smaller the pH gets. Right? So the larger H plus gets, the less this exponent is going to become closer and closer to 0, basically, right? Because so 10 to the negative 6th is larger than 10 to the negative 7th, right? 10 to the negative 5th is larger than that, etc., etc. And so as you move up, you're going to get smaller pH for acidic solutions. So anything that has a pH that's less than 7 is acidic, right? So we can define that, right? pH less than 7 equals acidic. Again, probably something that you've seen somewhere before. And of course, we can go the other way, right? Basic solutions have lower concentrations of H plus. Now this one's a little bit harder to kind of make sense of. Of course, this means they're going to have a larger pH, right? So a pH greater than 7 equals basic. Now, in a basic solution, remember that base plus H2O, we're creating hydroxide, OH minus, plus conjugate acid. So a base plus water gives us hydroxide. Now, when we produce hydroxide, what happens? Right? What happens to our H plus concentration when we produce hydroxide? The answer is the concentration of H plus goes down because remember, if the concentration of, switch over to me, if the concentration of OH minus is going up, overall, the product of OH minus and H plus has to equal 1 times 10 to the negative 14th. So if our OH concentration goes up, our H plus concentration has to go down because we always have to maintain Kw, right? Everything always goes back to that 1 times 10 to the negative 14th, right? So If we're producing OH minus, that means that we're reducing the amount of H plus. We have a lower H plus, which means we have a larger pH for the same reason, right? Because we have this negative sign in front of our log, the scale of the pH is inverse to the concentration of H plus. So larger H plus, smaller pH, lower H plus, higher pH. So high numbers are basic, low numbers are acidic. We can also talk about pOH if we want to. pOH, of course, doesn't get nearly as much use, but the pOH is just a negative log of OH minus, right? So we're doing the same thing, only instead of expressing things in terms of how acidic they are, we're expressing them in terms of how basic they are. So OH minus is going to be the opposite of pH in every way, right? Neutral pOH still equals 7, right? pOH of acidic solutions is going to be greater than 7, and pOH of basic solutions is going to be less than 7, right? So just the opposite of this. In fact, we can even say, because we know that the concentration of OH minus and the concentration of H plus are related by Kw, which is 1 times 10 to the negative 14th, we can actually say that pH plus pOH will always equal 14, right? Because if we take the negative log of H plus and add the negative log of OH minus to it, right, what we're really going to end up doing is taking what is the negative log of H plus times OH minus. And we know what H plus times OH minus is 10 to the negative 14th, and the negative log of that is going to be 14. So this is another one of those things that's always true, and the reason it's always true is because of Kw. Kw is everywhere, man. It's all connected. So Kw is 10 to the negative 14th. We use that scale to then kind of figure out H plus and OH minus, and those two things are always going to be related. So anytime we talk about this, we can always flip around. If we're talking about H plus, we can flip it around and talk about OH minus because it's related. They're related to each other, right? So all of that is great. The next kind of sequence we're going to start to talk about, we're going to define what are some strong acids and strong bases so that we know kind of what to expect in those cases. And then we get to the really interesting stuff, which is weak acids and weak bases. And that's where we get to use ice tables again. Get excited.